Hello, hello, hello. You see here a picture of a regular rainbow. I discuss rainbows in at least 5 of my lectures that are online. And before you do this problem, I suggest you watch one of them. And the one that may be the easiest for you is the 5th lecture in my playlist 1-hour talks for NHK in Japan. Watch that first so that you have a full understanding on what you see here. What you see here is the primary bow on the right, red on the outside, blue on the inside. The radius of that primary bow is about 42 degrees. And the center of that primary bow, the primary bow is a circle, by the way, and the center of that is the anti-solar point. It is the line from the sun to your head and then continuing in all the way through the earth. If the sun is 10 degrees above the horizon, that center of the rainbow will then be 10 degrees below the horizon. I explain in my lecture why outside the primary bow there is a secondary bow about 10 degrees further away. Its radius is about 51 degrees, and the colors are inverted. Red is on the inside and blue is on the outside. I also explain why in between the two bows the sky is very dark. Notice that here. And why inside the primary bow the sky is reasonably bright, white light. I even mentioned, but that is not so relevant now, that on the inside of the primary bow, near the blue, you will see that the blue is kind of strange. There are some dark lines inside the blue. We call those supernumerary bows. Don't worry about that. But have a full understanding of what you see here. In 1972, 48 years ago, I was for the first time at MIT going to lecture 803. The physics of vibrations and waves. And I wanted to make a rainbow in my backyard. And I asked my daughter Emma, who was then 7 years old, to hold the tube that we use to water the plants. And on the next picture, you see the result of that. You see that here. Emma is on the left, you don't see her yet. But you can see the primary bow, which is the result of water coming out of that hose. Water hose. Notice again that the inside of the primary bow is white light. And that the red is on the outside and the blue is on the inside. It was freezing cold. Poor little Emma. You see her here. If you would have stand next to me, you would have seen exactly what you see here. I will go back to the other picture. You would see this. Now comes the problem. Would there be any way, any change that I could have made or that Emma could have made so that I would see two primary bows? That's the problem. What should she have done or what should I have done? No tricks are involved. We're not talking about reflections in water. Nothing like that. And for those of you who are lucky to have my book For the Love of Physics, I mentioned that in my book. Okay? Have a nice day. Take care. Ah, you know what's missing? What do you think is missing?